Here's lab number 5, polarization 1, Malus Law, I don't know, some crazy European name. Anyways, so we have our setup here. We have our HENE laser going to a spatial diffuser, and then the chopper. Then the chopper is controlled here by a frequency controller. Then it's going through a polarizing lens. Then we're going through our prism, the gland prism for this first part, and then we're going into the detector. So initially we had a bunch of issues lining up the laser, so that's probably our greatest area of error as far as making sure that the laser really is lined up perfectly all the way down the line. We did the best that we could and seemed to have a pretty good lineup. The next thing in the procedural steps asked us to go ahead and set the chopper to a frequency that gives us a nice square wave. So our oscilloscope is separated by about 1 millisecond per division, and our frequency on our chopper isn't very clear, but it's between 2 and 3 kilohertz. And so somewhere in that range should line up appropriately. Honestly, it doesn't really matter what you set your chopper at, as long as the oscilloscope is set up in a way so that it shows a nice clean square wave on there. In addition to that, it's important to note that we do have a preamp from our photodetector where our signal is coming in into our oscilloscope in order to amplify the signal. The purpose of this is to try and eliminate some of the background noise that comes in from both the background light as well as just the laser intrinsic property of itself. So the procedure asks us to go ahead and find the maximum for the prism, which we went ahead and did, and then after that step it through in 15-degree increments. So the oscilloscope's going to go a little crazy while I do this. It's going to be a little bit too difficult to get it to trigger exactly, but I can try and do my best. And you can see here, if I just rotate the prism, our square wave amplitude goes up and down. And so that's important because our baseline is here at the bottom, and then our value measurement is the top of that square wave. So we went around in 15-degree increments, starting from our minimum all the way back to our original minimum, and we recorded those measurements.
Alright, the next part of the lab was to switch out the gland prism for another polarized lens. So we went ahead and threw that in there. Then we do the same procedures. We have all the same setup, same procedure. We're going to go ahead and find our minimum for our polarized lens. Go ahead and bring the trigger down here. We can find it. So we find our minimum, and then we record that angle and go around in 15-degree increments. And as you can see, as we move or rotate the lens, we get higher amplitudes. So then the last part of this experiment is to find the HR number for our polarized lenses. So first what we do is to set up our whole beam, we take both of the polarized lenses out and measure the intensity using our oscilloscope. Right, once we get that measurement, we go ahead and we put our first polarized lens back in. And we would go ahead and find the maximum for that and record that number. And that would be, then we can use our HR equation to find the HR number for our first polarized lens. Now to find it for our second polarized lens that we use in our experiment, we just throw it in there with the other one. And then once again, we would find our maximum with our oscilloscope, record that number, and then just plug it into our HR equation.